mobilize our network to help with debugging, being involved in our forums and our GitHub. We also do a lot of conferences where Matt does some speaking, or one of our other founders, Kes and Frank. And we're doing basically a worldwide tour talking about Aion and trying to build our developer and investor community. So it's been really exciting for us to be here in South Africa. We're going to be tomorrow in Johannesburg for the Blockchain Africa conference, and Matt will be doing a talk after. We're doing a similar meetup really close to the conference space, and then we're flying to Nairobi to do 2 events. One with a company called Andela, which is a kind of like a developer education company, and another place called May Labs. So essentially, we're just really excited to be here and share like the platform that we're building, and we're grateful for you all to come out. I want to make a shout out to Limus Labs, who has helped us so much in getting the word out. Yeah, so we got Matt Spoke here, who's going to take over and talk about Aion. We got a couple more team members here. I'm glad that you guys got to meet us all, and we're going to hang out a little bit after. So I'll pass it on to Matt here. Thanks so much.
Thank you. So we're just trying to figure out, this is the first time we do YouTube Live, so hopefully this is working okay. And then I'll walk over and I'll switch slides here. So thanks for having us, guys. So I'm Matt. I didn't have a chance to say hi to everybody earlier, but happy that you could be here. Hopefully you grabbed a t-shirt on your way in. And I think we have stickers. Did we put those out?
Yeah,
okay, if you didn't grab a sticker and a t-shirt, please grab a sticker and a t-shirt. So I'm going to tell you a little bit about myself, about our team, about what we're working on, the problem that we kind of identified in the industry that we thought needed solving. This is kind of the result of a few years of kind of build up to this particular problem that we've been working on. A lot of our team traces back to 2014 when we started working at the time on like the enterprise market, on how do blockchains and decentralized systems impact large institutions, banks and governments and insurance companies and others. And then, over the course of a few years, we kind of learned a lot of lessons, made a few mistakes, developed some cool stuff, and then it all kind of came together to figure out that this was actually a big challenge that we wanted to solve, which primarily is this focus that we have on interoperability. So a little background on me. Somebody asked me earlier what my background is. Not your traditional kind of developer or engineer in this space. I'm actually a chartered accountant. Started my career at Deloitte. In fact, the first blockchain team that I ran was at Deloitte, where I met a few of both my co-founders I met at Deloitte. And then we left in 2016 to start the company that's behind Aion, which is called Nuco. We're based in Toronto primarily. We're now starting to kind of expand that team. We've got a few people in Barbados, including Roland, who's at the back of the room, who's our country manager in Barbados. And we've got now a small team in Romania, and we're about to put a team into Shanghai in mainland China. So starting to do this global expansion. We're about 36 people, I think, at last count. And my 2 co-founders, Jim, who's our CTO, lifelong engineer, traditionally kind of worked in big finance, in large institutions like Morgan Stanley, worked for the Central Bank of China for a while, worked in a hedge fund, always working on kind of trading infrastructure. And my COO, Kesem, who also does a lot of these kind of presentations, who's got like a legal and tech consulting background. So that's a little bit about us. The team's developed a lot over the last few months. When we launched Aion, we put out the word about this project about March of last year. We published our white paper in July. The team's about doubled since July, and we're trying to do that again in the next 3 to 4 months, just kind of double the team again. So there's a lot of growth going on, not only internally, but we're also trying to get kind of engagement with the developer community, people that are interested in this problem of interoperability as it relates to like scaling on the blockchain. So, long story short, what led us to this is we started building a lot of applications for large institutions. So we've done work with government, with healthcare organizations, with banks, with insurance companies, telcos, and in every case, we kind of had the ability to build cool apps, but semi-functional apps. If you have any experience working with Ethereum, you probably realize that you can do some cool stuff, but it won't scale to any extent to what you need it to do, right? If you wanted to be able to manage millions of customers or millions of transactions, like none of this stuff works today. So before we started going any further into application development, we kind of stepped back and said, well, what's missing in the underpinning infrastructure of this network or this technology? And as the ICO market kind of picked up, if you follow the ICO market, if you're coin traders, you've probably seen a lot, like thousands and thousands of app projects. People say, hey, I'm going to build the decentralized eBay and the decentralized healthcare record system and all of these things, which, many of which are pretty cool, but from our perspective, most of which are probably way too early, in the sense that, if you tried to build Netflix in 1993, you probably would have failed at building Netflix, because there was something not yet there in terms of maturity and development of the technology that needed to be built for Netflix to be possible. And that's kind of the stage we see ourselves at in the industry. So what's different about the blockchain, if you're unfamiliar, is that we have this cool opportunity of having monetized protocols rather than these free open source protocols of the internet era. So there's a lot of money and research going into the protocol layer of the stack, which means that we can fund relatively large projects to build cool protocols rather than only looking at kind of consumer-facing applications as the money-making pieces of this infrastructure. So that's what started us down this path. So I'm going to tell you a little bit about the three areas that we focused on to get started. So I mentioned we started in kind of private enterprise solutions, and I'm standing right in front of this, so that's probably not helpful. So this is the buckets that we see a lot of projects operating in today if they operate in infrastructure. They're either building private enterprise infrastructure. So you've got projects like Corda, which is R3, the consortium of banks building private enterprise banking systems. You've got public systems, Bitcoin, Ethereum, Cardano, numerous others. You probably know these well. And then increasingly these days you have interoperability protocols. Rather than having kind of this flavor mix mash of all these things together, we started thinking about, could we build something that addresses all three of these concerns? How could you build a system that is flexible enough and modular enough to be either public or private? And how could you design into that system the ability to interoperate with other systems? So we kind of took all three of these as the beginning of our design. So when people talk about us as an interoperability protocol, it's not wrong, but it's really a characteristic of our protocol rather than the entire purpose of our protocol. So, some people use TCP/IP as an analogy to describe interoperability in the blockchain. How do you allow communication to flow between endpoints on a network? But you layer on top of that the ability to have an operating system as well as TCP/IP, as well as some sort of routing infrastructure all into a single system. So the analogy is not perfect. So we said we want our system to be able to operate privately and publicly. We want it to be able to scale on a single network, but also scale across many networks. And then we want it to be able to connect to any other system, either systems that we've built or system built by other people. So this kind of speaks to this idea of heterogeneous interoperability, meaning not all blockchains need to be designed the same way. So, connecting Ethereum to another Ethereum blockchain to another Ethereum blockchain is a problem that is being solved, but it doesn't solve the problem of how do you connect Ethereum to Bitcoin, to Hyperledger, to all of these kind of various DNA systems that are being designed by different teams. So that was kind of the problem statement that we set out to do. I'll skip through this a little bit because it just kind of reiterates more of what I said. But private and public systems, this kind of comes down, a little point on this really comes down to how do you achieve agreement on a network? If you're unfamiliar with blockchains and their architecture, it really is a system whereby multiple parties agree on the state of information at any given point in time. So whether that information is financial information, like who owns which Bitcoin at which minute, then you have a group of computers that all have to agree on that ownership, or whether it's medical data saying, hey, do all these hospitals agree on the state of a person's medical file? So in some contexts, public systems, you want anybody and everybody to be able to validate and prove this information. In other contexts, you want only a small subset of people, licensed people, authorized people to validate that information. And that comes down to how do you implement what we call consensus algorithms. So at what level at the infrastructure do you achieve consensus among all these participants? And how do you essentially swap out one type of consensus for another? And that's the big difference between what we call today private systems and public systems. So that flexibility in design. Second to that was scalability. And scalability to us is actually, the end goal really is scalability, and interoperability is really just kind of a step towards that. So how do you, for one, increase the ability to scale on a single network? And this came down to doing higher performance computing, higher performance execution of transactions, but also how do you use interoperability as a tool for scale? So if I have an app today, and how many of you are familiar with CryptoKitties as a kind of gauge of the room? CryptoKitties? Anybody own a CryptoKitty? Yeah. How much did you spend on your CryptoKitty?
Let's not talk about that.
Okay, so CryptoKitties, for those of you unfamiliar, is kind of a goofy app that got built on Ethereum that more than anything became pretty infamous because of its impact on the Ethereum network, meaning this one goofy app with a relatively goofy use case squashed the network's performance. It brought the network down to its knees. You couldn't process a transaction in faster than a day during those few days of the launch of CryptoKitties. And it kind of proved that there was a challenge with the scale on a single network. There's all this essentially collusion of traffic trying to hit a single execution environment of all these transactions trying to get processed and building up a longer and longer queue of people waiting to get their transaction processed. So for one, you could say, well, how do I make that execution environment faster? And that's what a lot of work is being done, kind of what we call the virtual machine. So how do you make that execution environment more performant? The ability to maybe do parallel transactions at the same time rather than having everybody stand in queue waiting. But for two, can I take any amount of that volume off of that one network and move it onto multiple networks? So can I say I want to build an application that has parts of its transaction throughput on blockchain A, parts on blockchain B, parts on blockchain C, and just have all of the final state of those transactions get recorded in a single place. So we see this as a scaling solution from both perspectives, if that makes sense. And finally, interoperability. I was talking earlier with some of you around this concept that we have of bridges, which, as the name implies, is like this intersection between blockchains. And how do we make sure that as we move data and value between blockchains, we still ensure that we can allow for various designs of two networks on either side of the bridge and still allow for the bridge to be managed in a decentralized way. Because one of the ironies of our industry is that most of you who have interacted with crypto have done it through centralized institutions like Coinbase, like wallet providers, like you. I don't know if you're maybe on Binance. Hopefully you didn't lose any balance today. But all of these are centralized institutions in a decentralized industry, right? So that's kind of the irony of the industry that we're constantly facing is the more we want to decentralize, the more we have to put in place alternatives to centralized trading systems, centralized kind of proof points. So if I wanted to say, hey, what happened on Ethereum so I can process a transaction on Bitcoin, the only way to do that today is to trust an exchange to do it for you. Or you know the person that you're interacting with, like in a very peer-to-peer way. So this is, the ability to decentralize that communication between networks. So with that in mind, this is kind of the high-level design of what we intend Aion to do. Some of which is built, some of which is being researched or built. But we call these three things: federate, scale, and spoke. So federating in our design is the ability to see a transaction as being disconnected from a single blockchain. So how do you move a transaction across networks such that you can have a sender on one network and a recipient on another network and have proof that this chain of events has happened, even though the chain of events is leaving a blockchain. So that's kind of federating transactions. And although I use the term transaction often, I just want to make sure that we're all on the same page. We talk about transactions very generically as being any type of change of information. So a change of information in most cases today is I send a coin from myself to you. It's no longer in my wallet, it's not in your wallet. Something has changed in the information of that chain. But a change of information could just as easily be I'm updating my address on like my digital identity, for example. And no movement of money has happened, but we still see this as a transaction because I've had to signal to the blockchain that something has happened. So any one of these transactions, the ability for them to move from one network to another, the ability to take an application and scale it, meaning, what I was talking about earlier, CryptoKitties living on more than one blockchain. A good example of this, a project we're working with, some of you may be familiar, called Bancor. Bancor is a system built on Ethereum that has, as part of its design, the ability to move the Bancor system on top of more than one network, so that you can have Bancor tokens on Aion, on Ethereum, and maybe on some other networks, and have the ability for that supply of tokens to move between these networks. So your access to users is it increases exponentially based on how many blockchains you join. And then finally, the ability to create spokes. So in this model, we're talking about like a hub and spoke design where you can use the DNA of this system to just replicate and create new systems and either keep the exact functionality of the system or swap out modules. Say I want a private consensus versus a public consensus, or whatever the case might be, to be able to build what we generally refer to as like domain-specific blockchains. So a blockchain only for banks in Canada, or a blockchain only for insurance companies in South Africa. And then be able to design the parameters such that regulators can get involved and have oversight on some of these systems as necessary, when necessary, or the complete opposite, just build a completely new public system that is kind of governed by the crowd that uses it. So these are the designs or the functions that we're building. So to show you a little bit of a snapshot of what that looks like from an architectural perspective, this is intended to show that there would be kind of blockchains built around. But for one, this network here is our Aion blockchain that we're kind of in test mode of right now. If you're a developer or you have any interest in kind of the mining side of the industry, by all means, I'd encourage you to kind of check it out and get a node running, join the test net. So for one, you can build and run applications on this network. Just like any general computing system, you can kind of run any generic logic on top of this network. But then you have what we call these bridges, which are groups of nodes that act kind of in a decentralized voting mechanism to make sure that as events cross from network A to network B, they're all in agreement as to what those events were. So, these groups of nodes would see something on this network, agree that they've all seen the same thing, and then send a signal into this network, and that would trigger another event, for example. On the perimeter of the network, we have 3 types of systems that we've envisioned kind of supporting. And this, we think captures the majority of the market today: existing public networks, existing private networks, or Aion spokes, meaning, copies of the Aion system. So existing public networks, we're starting off with Ethereum. We're looking at a couple of others in terms of like where we may go on kind of second integration, third integration to build bridges that would connect us to these blockchains. On private networks, we spend a lot of time in the enterprise market. So we spend a lot of time familiarizing ourselves with IBM's technology like Hyperledger, or R3's technologies like Corda, or JP Morgan's been building like an Ethereum fork called Quorum, which is like a private version of Ethereum. So all of these is like implementations of private networks that we want to be able to support. And then finally, this ability to create kind of Aion spokes, which is probably the easiest of these because the DNA matches, whereas these, they can be different case by case. With that in mind, there's 5 types of people, and I'll talk about these high level without going into them in too much detail so that I can pass it off to Sam, who's going to come up and talk about roadmap after. But this is the 5 types of people that we see interacting with the system. So when we talk about what's the system for, what does it do, and who's going to use it, you either fall into this category down here of people that are participating in the infrastructure of the system. So, in the scenario of Bitcoin, you'd call these people miners. In this scenario, I'll show you and I'll explain to you how they function, what they do, what roles they can play. Or you have users, and users are people that are using the system as an underlying infrastructure to build their own business process or application. So we've broken these down into 3 categories, although they're really using it for the same function. We're seeing more and more that existing startups with existing product lines and existing customer bases that built these things not on blockchains are looking to re-architect. They're looking to say, hey, how does a decentralized system apply to my environment? Whether you're building a lending marketplace or a payment system or anything, like the number of use cases are kind of infinite. So to bring these users in, because we're looking less so at how do we capture the mind share of the existing 1% of blockchain developers, we're saying how do we go capture the mind share of the 99% of developers out there that have not yet built anything on a blockchain. So to bring these users in, it's all about tooling and simplicity. How do we make this as familiar to them as possible so that they can take the skills they have from previous software development skills and reapply those into the blockchain space? So we're spending a lot of time on kind of tooling, frameworks, simplicity of development so that these developers can migrate over relatively easily. In the enterprise space, it's that plus the ability to provide kind of an enterprise support function. So if you think of technologies like Linux that have essentially entire businesses that got built like Red Hat, simply to support the specific requirements of enterprises that wanted to use Linux. So we've got a couple of partner companies that are going to be starting to build this kind of enterprise support function around our kernel technology. They still need, all the development tools that these startups need. They still need all the, frameworks and language support that these startups need, but they also need a little bit more hand-holding and a little bit more kind of support behind that function. And then finally, the dApp developer is really like the existing blockchain developer who's been building Bitcoin stuff or Ethereum stuff or, other stuff for the past couple of years, and showcasing to them that there's a new case to be made for why applications should not be locked onto single networks. And that's really our hypothesis behind this is right now, you're essentially being asked as a blockchain developer to have vendor lock-in the day you design your app. And we don't call it vendor lock-in in this industry. We say, hey, I'm going to build an Ethereum app. It's locked into Ethereum. I mean, it's been built from start to finish to function on Ethereum's code base, to function on, Ethereum logic, et cetera, et cetera, et cetera, where really applications should be agnostic from what underpinning infrastructure they're working on. So that's kind of the case to be made to these app developers to say, you should not tie the success or failure of your app to the success or failure of the system it's built on. You should allow that app to be portable or to be duplicated in multiple places or whatever the case might be. So that's a big focus for us is kind of capturing that mind share. At the infrastructure layer, validators and bridge builders are really what allows the system to be secure and to continue operating without centralized control. So this is a decentralized system, meaning that there's a group of servers around the world that have to validate that the transactions hitting the system are valid, authentic, that they're not being duplicated, that nobody's trying to cheat the system. So these are the validators. In the long-term design of the Aion protocol, Sam will talk a little bit about in our roadmap, you've got 3 mechanisms to participate as a validator. You're either a core validator, which means you're actually building the blocks and building the transaction sequencing, and you're actually kind of creating the historical events on the network, or you're supporting one of those core validators. And you can be supporting those core validators by providing computing power to the system or providing financial deposit into the system. So we call these solvers and stakers. So there's kind of 3 core functions that you can play depending on sophistication, depending on like what resources you bring to the table as a validator. The second type of infrastructure is the bridge builder. And the bridge builder is less core to the Aion blockchain. It's more core to those intersection points. So all of those points that say, well, how do I create that overlap between Ethereum and Aion? And what we used to diagram, which is less articulated now in our designs, was kind of this Venn diagram, if you can kind of picture it that way, where we have blockchain A as a circle, blockchain B as a circle, and the bridge is that point in the Venn diagram where they overlap. That group of nodes that is common to both networks, that has the ability to see transactions and propose transactions on both networks, but then has a mechanism by which they make sure they're always in agreement with each other before they do that function. So that's the bridge builder. And how do you incentivize these bridge builders? You essentially create a secondary economic layer to say that if you build a bridge and validate transactions as they cross the bridge, then you can earn a reward for that. And that reward is paid in essentially the Aion currency. So that's kind of one of the core focuses of Aion, is how do you validate this layer of infrastructure that doesn't exist today. So hopefully that's relatively clear. We can jump into some Q&A after, but so I'm going to skip through these next few slides because they kind of reiterate that in more detail. A couple of example use cases, and then Sam's going to come up and talk about roadmap for those of you who've been following the project. So right now, a lot of the interest in this industry is tokens, coins, trading, all of that, right? All that great speculative stuff that really has nothing to do with what anybody's building. But it absolutely is kind of a core requirement that we have more infrastructure around the token economies that are being built. So trading infrastructure today, as I mentioned, is very centralized. It's very vulnerable to attacks and risks of thefts, et cetera. So building decentralized exchanges is becoming very topical. And you're seeing decentralized exchanges pop up in larger numbers. Most of them, if not all of them today, are decentralized exchanges on top of one blockchain. So projects like Ether Delta or 0x or whatever, where they can move tokens so long as those tokens are from the same network, because they have proof of these events, and they can kind of trade between one ERC20 and another ERC20 because they're on the same network. So the concept of decentralizing exchanges across blockchains is becoming more and more topical. Can you decentralize the transaction from Bitcoin to Ethereum? And that's a challenge that's not yet perfectly been solved, and definitely a use case where Aion could fit in. I don't think it's the most, the best example of the value proposition of what we're building. Because if you want to do kind of token swaps, there's tons of designs that are very singularly focused on token swaps. Where we kind of think that the longer term use case for using Aion comes in is how do you create decentralized applications that are more logic driven than value driven, that sit on top of more than one blockchain. And so one of the examples we give just to help people kind of capture what we're talking about is how do you use blockchains for something other than financial transactions? And how do you allow these different applications to connect to each other through a protocol like this? So simple example, you have a network of hospitals that all share a common blockchain for the purpose of maintaining a single state of information on a patient's medical file. So a group of hospitals in a country, for example, instead of all maintaining replicas and somebody's got the most recent version and somebody's got an outdated version of a medical file, you're all looking at the same medical file at all times because it's this kind of private closed group of hospitals. So it means if I get an operation, that operation is reflected in my medical file. That medical file is automatically shared by all these hospitals. And if I get an operation in that blockchain, it's a transaction gets added to the network. And now I've got a insurance policy. Let's say I've written a public insurance policy on the Ethereum blockchain. So I've got a smart contract that dictates that people are going to fund me for medical operations if this criteria, that criteria, and this criteria are true. So how do I allow that Ethereum smart contract to verify the state of my medical records on a different blockchain? So this is where we get into like cross-blockchain applications where you might have one is a private network, one is a public network. And maybe Ethereum makes me a payment. There's an Ether payment that comes into my wallet because the policy covers my operation. Or maybe it needs to send a message to blockchain number 3, which is like a private banking network. And that's where the payment gets made. Whatever the case might be, is this kind of idea of being able to move logic between these different applications on different blockchains. And then finally, right, what we're seeing right now is that there's a lot of interest in using Aion as a scaling solution for Ethereum and for other public blockchains in general. But can you move transactional throughput off of the Ethereum chain, process that transaction execution, and then just bring back to Ethereum a single final state? So you go back to an ICO, for example. If you were in the industry at the time of the status ICO, which was kind of infamous because, again, another example of the network just crashing to its knees as a result of a single application on a single day. what could have happened on the status ICO, instead of hogging all of the throughput of the Ethereum blockchain, is the status ICO could have been built on another blockchain. You could have said, hey, I'm going to run all of those purchase transactions on a separate blockchain and only send back to the Ethereum blockchain the final state of ownership. So at the end of that, that ICO, that very high frequency throughput ICO, I send back like kind of a spreadsheet to Ethereum, for lack of a better analogy, that says, here's the state of the owners of who bought status. So Ethereum gets essentially a single transaction as an output, rather than like 100,000 transactions going through the network in a very short period of time. So using these as kind of like off-chain transaction kind of scaling solutions is something else we're working on. And that's kind of the main purpose of our first bridge, which is the Aion to Ethereum bridge. So I'm going to stop there because I think this is where we jump into the roadmap. So Sam, who just for context is part of our team in Toronto, he's very much kind of involved on all the strategy side of Aion, a lot of the public communication side of Aion, and a lot of the kind of white paper analysis that we do of other projects that are working with us. So he's going to come up and talk to you guys a little bit about where we're at, what our roadmap looks like, and some of the deeper pieces of what we're building. So Sam.
Cool. So this is kind of our roadmap as a high-level overview. I'm going to go through each piece kind of individually, talk about what it's about and where we are in the progress. So first of all, this is kind of where we are today. So we just passed through this big milestone, which is the Aion testnet. Does anyone, like, raise a hand, does anyone know that our testnet came out? And is anyone on the testnet, downloaded a node? We got one person. Okay, that's good. But I highly suggest that you guys, when you go home, take a look on our GitHub. It's actually really easy to download. I come from a non-tech background, and if you can just download Ubuntu and you can go through all the directions on our GitHub, it's really easy. And for those of you that are just interested in the project, it's a great way to start playing around with it. And I'll kind of talk about it later, but we also have a really great bounty program. So for those of you that are going to download and participate, you'll get some bounty and you can kind of start mining the network. So it's a great opportunity. So this was the milestone that we most recently passed. And what we're working towards is this phase 1 release. So slowly we've been releasing code. And a few weeks ago, we did the full open source release of this phase 1. So that was all our modules, our virtual machine design, our consensus algorithm. So we're working towards this mainnet launch for kind of mid Q2 of this year. So we're really excited, and all that code's out. So again, check it out on GitHub. The core piece here is kind of getting the initial Aion blockchain up and starting to get people building on that blockchain. So this is dApp developers, miners, all these pieces that make up that ecosystem. So as Matt mentioned, I've been working with a few projects that are interested in kind of what we're building at Aion and starting to get them to look towards either launching their application or building their project or their future business. So we've had a lot of really good interest there. Following that, we have a series of papers that kind of get more technical in terms of some of our long-term pieces. So this is proof of intelligence consensus, our generic bridging protocol, and then our wider economics paper. So on the economics piece, a few weeks ago, we also released our monetary policy. So that's another easy read. If you're not too technical, this is more on kind of the general Aion token economics. And we have a kind of cool piece on, I think, the 3rd or 4th paper that'd be great to get kind of the community's reaction on. Is one of the interesting pieces is that Aion, as kind of a coin, is going to live on multiple networks. And there's that kind of implications of living on multiple networks because the coin is going to function in the incentive mechanism on different consensus processes. So we have to start thinking about those considerations of how do we use this kind of single currency for the right incentive mechanisms in a proof of work environment and a delegated proof of stake environment, and for our new consensus of proof of intelligence. So that's like a cool research topic that's ongoing. So highly suggest reading about that. And then after that, we have our phase 2 release, which focuses on our initial AVM design, the release of our Aion scripting language, and the introduction of proof of intelligence. So these, again, are kind of the building pieces to lead to the Aion 1 release, which is phase 3. So this is the introduction of first version of the AVM, which will start to build on kind of the fundamental pieces that we need, and then focus on proof of intelligence, which will ultimately be kind of the hybrid consensus model in Aion 1, which is phase 3. So I know that there was a lot of information, so I'm going to go kind of deeper into each one of these pieces. So consensus. So this is a cool little diagram. This is from our white paper. We probably want to update it for our brand because it doesn't really make sense anymore. But where we're at is there's kind of 3 releases in regards to our consensus. The first is what we have out today on our testnet, and which will be the first part of phase 1, which is the Aion proof of work release. So Aion proof of work release runs on what we call Equihash 210.9. And 210.9 is the idea of our parameters are 210 and 9. So what we did is a change here on our parameters compared to what there exists today in Equihash. So for those of you that might have not have heard of Equihash, Equihash is the consensus algorithm that's used by Zcash, Z Classic, Zen Classic, or sorry, Zen Cash. There's I think 5 or 6 different kind of privacy related or general coins that run on the Equihash algorithm. And the vast majority of run on something called 209. So that's the Zcash implementation. And what we did is we took that implementation of Equihash and hardened the parameters. So we increased the parameters for increased ASIC resistance. So what this allows us to do is it kind of further democratizes miners for those GPU or CPU miners. And then it also adds some redundancy in the consensus kind of space. So when you have a lot of different projects that are building on one algorithm, there's a lot of focus towards kind of building ASICs for that algorithm. So we thought we'd create a novel algorithm to also prevent kind of a focused ASIC build for Equihash. So that's where we're at on the proof of work consensus. And then we have these 2 new pieces. So for some of you that have been following consensus, DPoS has become a big topic. It's featured by a lot of projects like EOS and Lisk. And it's a really cool concept. And we're looking at it for how it's involved in our scalability discussion. And what we're introducing is this idea of hybrid consensus. We haven't really come up with a cool name for it yet. So again, if you have suggestions there, we'll probably give it a bounty for a cool name. I have a few ideas, but I don't think they're that good. And the idea here is you have 2 inputs into consensus. So the way DPoS works now for a lot of networks is it's a kind of a staking mechanism. So anyone as a general coin holder can take their coins and stake it and vote for validators to participate in a delegate pool. And this delegate pool could be anywhere from 21 participants to 110. We've seen a whole variety of that amount of kind of decentralization in the staking pool. And what we're creating is a hybrid version of that. So there's 2 ways as a user to input. You can input as a staker, as like a traditional DPoS model, or you can input as a solver. And this is what Matt spoke about in terms of proof of intelligence. So what's novel about this concept is it's kind of a traditional mining function mixed with a staking function. The traditional mining function is proof of intelligence. So I can provide computing power into this neural network and prove that I have a bit of stake to that compute power. And then that'll allow me to kind of participate on the same playing field as these stakers, and then vote for people to participate in this delegated pool. So the benefits here is that you kind of have decentralization in the backers. So instead of having one kind of unit to input in, which is staking as in the coin, you can also participate in the system through generic computing power in the form of kind of contributing to this neural network. So you add to the decentralization there. And what we're working on right now is researching what that balance is. And this might be a dynamic balance. So if you have a lot of people that are starting to stake through the coin, we would shift the incentive towards people to participate in proof of intelligence. So this is some of the interesting research that's ongoing, and this is going to be part of our phase 2 and our phase 3 process. So we have a few PhDs back in Toronto that are working on proof of intelligence, and then our delegated proof of stake we're also in research for. So the VM. So as I mentioned before, for the phase 1 release, we have a modified EVM. So what we did here is we took the EVM that exists today in Ethereum, we forked it, and we did some modifications to the data word size. So we did, I think I just heard you laugh when I said fork, but that's okay. So there's, what we did here was change the data word size from 256 to 128. And what this allowed us to do is to kind of increase the speed at which the virtual machine executes. And on our benchmarking test, it's around 50% of the speed. So what this means for dApp developer, the execution of your contract will be 50% faster. And what it also resulted in was we introduced LLVM just-in-time execution, and that resulted in roughly a 50% decrease in gas cost. So gas in the Aion network is called energy, but it's a 50% cheaper gas cost to run kind of your standard contract. So that's some of the initial benefits for dApp developers to look at building on Aion is you kind of have faster, cheaper dApps. And those will ultimately get quicker and quicker as we release the Aion virtual machine. So over here, we have a bit of a diagram, and this is around kind of compatibility of the virtual machine. So right now, with the modified EVM, if you're a Solidity developer, the same Solidity code that you use in the EVM, you can use in the Aion environment. So whether you're building smart contracts on the Ethereum ecosystem, you can take those contracts you built, and they're it's like 99% compatible with what we built. There's a few assumptions that we have posted in terms of the migration guide, but generally it's going to be very compatible. This diagram speaks to the AVM, which is we want to support multiple smart contract languages. We'll have the Aion language, we'll support Solidity, but as Haskell or other languages get popular, we'll also try and support them into the AVM compiler to support that bytecode. Bridge. So this is a fun topic. We were just talking about the Dog ETH bridge earlier, which is the Doge ETH bridge, which is really cool. But so the idea here is we have kind of a few releases around the bridge design. The first one is the token bridge between Ethereum and Aion. The first design is quite specific in this bridge release, which is to take the Aion ERC20 and then move it through a decentralized mechanism into the native Aion currency. So if you're a holder of the ERC20 token, using our bridge protocol, you can move that autonomously and you'll get minted an Aion coin on the other side. So this is a really cool bridge design that we think other projects will also be interested in for using to either kind of take their existing token that they have in an ecosystem and move it to the new blockchain that they're building. So we're hoping that we get a lot of kind of use out of that bridge. And then following that, and in parallel, we're researching and building the generic bridge. And this will go through multiple releases. The first one might be similar to kind of what we've seen in terms of ERC20 to ERC or smart contract to smart contract bridges. But the first release will probably focus on how do you move a token from one ecosystem through a decentralized bridge into another kind of smart contract-based ecosystem. And then further to that, it'll be focused on the logic movement between two different blockchains. So ongoing research and development on both those pieces. I think the next slide is the vision, which I think I'll invite Matt back up to you if you want to talk about the vision.
Yeah, I think that's almost it. I just got a message from somebody saying they were watching on YouTube Live, so somebody's doing it. Hey, Alistair. All right, cool. So quickly about the vision. I mean, we talked about this, I guess throughout a little bit, but a couple of random logos that we threw up, but kind of the message here is that what we see as being relevant is kind of two things. One, we started this design with a very simple philosophy that all chains should be equal in this final network of many networks. So although we often illustrate that Aion's kind of at the center of this multiple network blockchain, what we expect will likely happen is that you're actually going to have multiple blockchains that operate as bridges for each other. So, this is kind of more of a spider web without a middle rather than like a hub and spoke model as we move. So you'll notice like as we go through this image, and it's obviously just a design, but you might have a blockchain that operates as its own hub to other blockchains. So you end up having kind of multi-tiers of networks that connect to other networks. And in the context of us connecting to projects like OneChain, in OneChain's design, we are connecting to them, and our design, they're connecting to us. It's really just a matter of perspective of where you're sitting in the industry. But kind of core to this is the fact that we see over time a explosion of number of networks. I mean, our assumptions are built on the fact that hundreds of thousands, if not millions of blockchains are going to exist at some point, and they're going to be completely unknown to the people who use them. They're going to be sitting behind layers and layers of systems where you're not going to understand where these transactions are being cleared or processed, but they will be happening on some sort of blockchain underpinning them. And they'll likely happen on a smaller and smaller number of protocols. That's one of our assumptions. Meaning, if you have 100,000 blockchains or 1 million blockchains, maybe they're being built on 10 protocols. You might have 100 versions of the Ethereum protocol operating on 100 blockchains, the Bitcoin protocol, the EOS protocol, whatever the case might be on different networks. So part of our design is that. The other thing that we also, we don't really subscribe to the idea that everything needs to be decentralized all the time, and that there's this spectrum of decentralization from private networks to public networks, but also from centralized systems that are probably still going to continue to exist. Systems like SAP and Oracle that have a massive amounts of market share and provide very, very complex functionality that, in all honesty, would be very difficult to replicate on top of decentralized networks. So building connections in and out of these centralized systems, and I threw SAP up there as an example, is just as important as building connections between two decentralized systems. So at this layer of bridge, I mean, you've probably heard the term, if you follow the industry, you probably heard the term oracles, or at some stage, this is all kind of like a large-scale Oracle system where I can validate that something happened somewhere else and bring that proof in, whether it happened on another blockchain or it happened on a centralized system, whatever the case might be, but using at those proof points as much decentralization as possible and an economic layer to make sure that people continue to act honestly. So this is kind of where we see the project going over time, is kind of capturing some of the imagination of more and more of these projects. I think from an app developer's perspective, there tends to be a lot of tribalism today, but as we go for the 99% of market share that hasn't been tapped yet, people don't really care or should not care. Am I building on Neo? Am I building on IOTA? Am I building on EOS? Or am I building on Ethereum? So really it's a matter of setting up and creating that set of tools where you can kind of obfuscate that for the average developer who's going to be building these future processes and future business models that we all are probably going to be using and relying on in the next 5 to 10 years. So that's kind of the long story short. I'll give you a quick snapshot, and this is outdated kind of week by week. This is a quick snapshot of our team today. It does not have a few of our guys, unfortunately, so our Barbados team is not on here. or our Romanian team. But anyways, this is constantly updating. And then finally, if you want to follow the project and get involved and kind of see where you can find more resources, more and more of our conversations are being directed to, if you're a developer, get on GitHub, start interacting with our team there. If you're interested, either if you're a developer or you're just interested in kind of the tech in a little bit more depth, join our forum. There's tons of conversations going on our forum. We also have a Telegram channel, et cetera, et cetera. You can find us kind of in many different places online. So hopefully that's helpful. I'll stop. I'll take a few questions. Before I do, Jay's going to be handing out. Have you handed them out? No, you're handing them out. Okay, Jay's going to be handing out a little page thing. We'll do like a quick raffle for 2 of these. We'll win 200 Aion. So if you fill them out and hand them back into Jay, we'll give out 200 Aion to 2 people. Yeah.
Have you wrote a lot of pens?
Question is,
What's up?
So what's your partnership in the next couple of months? Let's say again.
Partnership strategy? You mean who, or like what are we focusing on? Or
Like you partner with any other blockchain technology company or they have
yeah, so
on the economic side, you partner with any company, hedge funds, whatever.
yeah, sure. So we've announced a number of kind of quote unquote blockchain partnerships late last year, kind of November, December of last year, projects that we're working on that are blockchain software companies that we see a lot of overlap in terms of what they're working on and what we're working on. And at some layer, we intend to collaborate. So depending on the project, Bancor is one of our partners where we're really looking at how do we not only apply their design about token liquidity to the Aion token, but also our design about multi-chain token systems to them. So we're always looking for this kind of mutually beneficial relationship between us and a partner. What we've found is that you look at all the blockchain projects in the world, you're probably going to find that component by component, there's a lot of people duplicating efforts. Meaning there's a lot of people building better virtual machines and a lot of people building bridge functionalities, and they have nuances to how they're doing it, but there's a lot of like reinventing of the wheel that's happening over and over and over again. And there's only a small pool of resources that have been raised by all these projects, and it's an inefficient use of resources. So as often as we can, we're looking for projects that have similarities to us. And the perspective we take with these projects, and we did this, we launched something in December, November, called the Blockchain Interoperability Alliance, which is us and a project called WANchain and a project called Aion, that are also focused on kind of different layers of interoperability in different contexts, but where we think that we can learn from each other's designs and best practices and try to get to a standard rather than building 3 competitive standards. And the perspective today is that if we're at this like 1% or less adoption, which I think is less, the real opportunity for any company in this industry is like market growth rather than competing over market share. Like it's not how much can I steal from the other blockchain project, is can we both work towards growing the market by 50%? And that's where, there's tons of white space out there. So at the VM layer in the execution environment, we are talking to a few projects that are also, heavily focused on improving virtual machine performance. Where one of the intentions we have is to get to kind of an industry standard and best practice on how to build high performance virtual machines. Not an Aion standard, but like an industry standard that many companies kind of collaborate on. So as often as we can, we're doing that. For one, so that we don't waste our own resources, and for 2, so that not everybody out there is just kind of duplicating each other's efforts. I mean, it is naturally a very, very open source industry. Not 100% open source, but extremely open source. So one way or another, we all end up learning from each other anyways, because we're all looking at each other's code, reading each other's papers, and kind of taking best practices off each other. So we formalize that through partnerships. Increasingly now what we're seeing is we're getting partnerships that are more aligned towards people building businesses that would sit on top of our protocol. So applications that see value in the concept of like a multi-chain framework where they can run their application on top of more than one network. So that's a big focus over the next 6 months on the timeline you asked for, is projects that want to use the Aion protocol as the underpinning infrastructure for them.
In a nutshell, what you past partnership results.
Yeah. No. So I'll say historical partnerships have been mostly focused on the protocol. A lot of our kind of next 6 months partnerships are focused on the application. So
on this partnership, sorry, I just need to get to.
Like a company's name?
Yeah.
Oh, so we're not at that stage yet where I can announce these company names. It's not just up to us; it's also up to these.
Last question though. Your product is awesome. I'm a huge fan. I have these clients quite interested.
Yeah.
And I'm here to learn more.
Sure.
A lot of projects are similar to. It's kind of similar to Cardano, and if I just came up with something called Antos, it's kind of doing exactly the same.
Okay.
Bridging blockchain all things together in one space, and then integrating it. Right? Why should I go to Aion? Why Aion?
It's a good question. I mean, one of the things that frustrated us in this industry, and we actually got criticized a lot for this in 2017, was that we spent little to no effort marketing our project. And if you compare us in marketing fluff to other projects, we're probably the least performant marketing fluff company out there. So I think what you should be focusing on, and right now is kind of it's an arbitrary point in time, but looking at projects as they progress, as to like how much substance is getting proposed and built and put out there. So there's tons of projects that you'll find probably have the best web presence, did $100 million ICOs, and are promising the world and everything in it to everybody. And then you'll try to find a single evidence of substance and you'll fall short. So, developers tend to get drawn towards substance and code and, well-built ideas. So I think as long as your focus is there, our intent is to compete on substance. So, if we're falling short on substance, it means we've got catching up to do, and we're continuing to put effort into like moving our roadmap forward. But we're going to be relaunching a lot of kind of our branding and a lot of our, quote unquote marketing, really focused on just developer adoption and developer traction. So, you'll never hear us talk about the market economics of our coin. It's not our driving, KPI for the company. So, we trade at a $300 million market cap. Cardano trades at an $8 billion market cap. We don't care, because at the end of the day, we think functionality-wise, projects are going to be discerned by, they're going to be judged by what is that core functionality you built. And we're still at this point in the market where, the general metrics on how we're valuing projects is all a whole bunch of ignorant speculators valuing projects that they don't understand. So can we get to a point where we're valuing projects based on like reality and substance? And I think we're years and years away from that. So, long story short, if you got anybody who wants to talk directly with us on a technical layer, we're happy to put our team onto that, where we do a lot of kind of one-on-one technical calls, kind of dive through what we've built, what we're about to build, what we're about to release. So, that's something that we can do. If you want to connect after, we can kind of trade the contact info on that. Cool. Yeah.
In the slides, you spoke about the generic bridges that you want to build. I wanted to know how developers fit into that, because in the previous slides you had where developers would help develop these generic bridges, but the slides were talking about how you have your internal researchers researching these generic bridges.
Yeah.
And how does that fit well into the model where you have more blockchain networks coming on and attaching to them?
So I think, two things. Our generic bridge design is intended to probably capture 80 to 90% of the core functional requirements of building a bridge, with the 10 to 20% being the unique characteristics of the blockchain you're connecting to. So we'll build, a generic bridge design that is perfectly functional for an Aion to Aion connection, and likely a generic bridge design that is perfectly functional for an Aion to Ethereum connection. Anything that is slightly varied off of that initially will require kind of some sort of adaptation, like a change of the code, essentially. So if we could kind of put out there the spec of what a bridge looks like, and you want to connect in, for example, one of the companies that we work closely with is a project called Eternity, and Eternity is building their own blockchain protocol with some unique characteristics. And we're likely going to start working with Eternity on a different bridge design that is Aion to Eternity, which would be slightly different than the bridge design from Aion to Ethereum. What we'll likely do to kind of engage the community, as Sam was mentioning, is we're moving more and more towards kind of an incentive model to get active development of adoption and participation and commitments. So at a bridge level, if you build a bridge that does, Aion to X, whatever X is, there may be bounties and grant money associated with building those bridges. Taking the model of what our template bridge looks like and just kind of making the modifications to get it functional on like a slightly modified version of that network. So you'll probably find that in 80 to 90% of cases, the bridge that we put out there will be functional, and then you'll need 10 to 20% of like edge cases where people have to make some tweaks. So, yeah. Cool. Any other questions, guys?
Yeah, sure. So in your example that you have about the ICO, where you do it off-chain to get the speed throughput at the end of the day, how would that be different, or how would that compare to a state channel or a plasma protocol on the original mainnet, where you could still do it off-chain while being on-chain and then still submit the final state? I mean, wouldn't that be actually faster than using the Aion as off-chain?
Yeah, I mean, to the extent, I think in their current kind of design and implementation, Plasma is probably going to be able to solve this once there's more actual substance put behind it. Same thing with state channels. There's a really cool project called Counterfactual working on state channel implementations. I think as it relates to the Ethereum ecosystem, there'll be very specific Ethereum extensions that get built, right? So state channels in Plasma kind of focused as extending the Ethereum ecosystem exclusively, where we're trying to build something a little bit more generic that can be applied not only to Ethereum, but to anything else as well. So this idea of being able to scale off of a main chain that is bogged down by transaction throughput, the only real example today is Ethereum that gets bogged down by transaction throughput. But at some point, that problem will exist on many networks. And rather than having a protocol that has to get built to a single network spec, so Plasma to Ethereum, and then let's say EOS picks up and becomes a massive network, and then you need to build kind of the Plasma equivalent to EOS, which is kind of already part of their design, have something generic that can apply across all.
So eventually there's going to be a blockchain that doesn't have their Plasma.
Yeah, they can use
this.
this. And right now, it's really a matter of like, we don't see the long-term purpose of this being simply a scaling solution for Ethereum. We're just saying that this could be what a developer decides to use it for. If you're waiting for a more functional, more scalable version of a counterfactual state channel or of Plasma to get implemented, and you've got like a functioning code base that you can just run and use, then you may as well start there and then migrate over at some point. The other thing that we work on in like designs of ICOs or new token systems is if part of your design is to eventually exist on your own blockchain. So you may launch a token as a token on and this is kind of what we did, right? We launched a token on Ethereum, and then we want to eventually migrate that over to a native coin on our own blockchain, but we have kind of a transition phase of what that looks like. So this is, the ability for somebody to do that and migrate their coin over as part of like that scaling solution where we can actually build their blockchain for them very, very quickly. Because one of the things that a lot of projects are working on right now, which is an unnecessary use of effort, is you've got some application, but you're also building your entire kind of backend stack yourself rather than just leveraging someone else's infrastructure. So you can make it easier for people to kind of customize and deploy their own blockchains that have most of the features they're looking for, rather than everybody having to build everything like custom from scratch. So you can just pick some modules and launch your own blockchain, and then launch a token, raise some money, and then migrate that supply off pretty instantaneously. We think that that'll be relatively well accepted.
That's the spoke mechanism, right?
Yeah.
Does that have any connection to you?
What's that? No, no, and I try to separate myself from this. Probably nobody believes me when I say this, but I push back on that naming, and it just stuck because of the hub and spoke design. And we didn't come up with the term hub and spoke. I just so happened to have that last name. Yeah. Any other questions, guys? Yeah.
You mentioned a partnership with Trinity.
Yeah.
Is it just a bridging, or is it possibly forking their virtual machine as well when that comes out?
Yeah, we're still, right now, the first discussions are around bridging, but we're looking deeper into their roadmap to figure out what other layers of kind of overlap there might be. To the extent that, what we're doing right now in terms of coordinating this like VM collaboration. So we're going to be contributing a lot of our VM research and implementation, and we're trying to get a bunch of other projects to do the same. That's something that we'll be talking with Eternity about as well. But it's too early stage right now.
You could be supporting multiple languages as well.
Yeah.
So it's just,
yeah, we will be supporting multiple languages, whether we do it on our own or whether we do it in collaboration with others. The intent is that the compiler that we build on top of the AVM, because right now we've released essentially a modified version of the Ethereum virtual machine as kind of a first implementation to get the network out there and to get some adoption around it. But our longer term design on the VM is to run what we call the Aion virtual machine, which has a couple of key characteristics. One being kind of a generic compiler that can support many languages at the smart contract layer. So yeah, that's part of the roadmap one way or another. Did you have another question?
Yeah, so if we talk about proof of intelligence at the end of the day,
yeah.
I mean, neural net's power comes in unsolvable problems. We're talking about N equals NP problems.
Yeah.
So the way you guys are designing proof of intelligence, the result needs to be validated. But a proper neural net by design can't be copied and can't really be validated. So the only way you can have proof of intelligence on AI-based problems is if you already know the answer, and then you're defeating the purpose of leveraging that processing power to solve any equals.
Or if you can validate the answer after it happens. Like if you're trying to predict the probability, and then you're essentially saying, well, the change in challenge is saying instead of proving a harder and harder problem on the basis of difficulty in the proof of work mechanism, is you're proving a problem and increasing the expectations on accuracy. And saying, well, how accurate were you at defining that output? And that output eventually can be measured against the reality. Like if you were trying to predict the future event, or you're trying to predict some sort of probability associated with something, and at some point it comes true or it doesn't, and you can kind of measure expectation out of your neural net versus reality, and that becomes the measure.
So it's close to a confidence rating in image recognition.
Yeah, that's right. Image recognition is a good example. You know how many cats there are. How good was the computer at telling you how many of these were cats, right? So it's kind of applying that same concept.
But the problems themselves in the proof of intelligence, will you actually like do a Kaggle kind of thing and like crowdsource them?
Yeah, it's kind of TBD right now. In terms of where we source the problems, we're still figuring out that mechanism. Right now, functionally building the mechanism to be able to consume a problem and solve it. At some point, how do you source the problems and the other thing is if you take proof of intelligence as a standalone module and say, I want to run different spoke chains inside the Aion ecosystem and have each of these chains kind of solving a different subset of problems, that might be one model where you say, hey, there's a chain solving, cat image recognition, if you ever needed that. Maybe it fits into CryptoKitties in a unique way.
It'll be there.
And that could be the problem going into a proof of intelligence algorithm on a single chain. On the main chain, we're kind of still figuring out how we source problems.
So I mean, there's also a monetization angle there for you actually renting out.
Yeah, where you can crowdsource, like you can charge for this network to solve your problem or whatever, and that can become part of the strategy that ends up kind of paying out the solver in that context. The other thing is that you end up designing more optimal hardware that is like designed intentionally to be better at solving neural net problems, essentially. So part of that move towards what we started doing on the Equihash is kind of like insisting that more specialized hardware get developed rather than generic hardware. And over time, that same concept kind of gets replaced with proof of intelligence, where we'd like for specialized hardware to get developed to be optimized towards these neural network problems rather than just generic proof of work problems. And then they can have dual purpose, right? You can use them to mine or validate proof of intelligence, or you can just use that resource to actually monetize in like an AI marketplace.
Can I just keep going?
This is a question for that.
Just a question. Just take it through. What I like about is almost interesting that I always want to say being able to develop one running multiple chains.
Yeah.
Okay, so is that, for example, I like a smart contract on this chain, or someone has exposed a smart contract on that chain, and I want to put something in there and get an output to actually be able to do other work on other chains, for example. Is that kind of the thinking that you guys are going to go?
Yeah, that's one way to think about it. I mean, let's say there's like an existing well-used smart contract system on Ethereum, and you want to build an application that interacts with that smart contract. Today, that would mean that your application needs to be built on Ethereum. So we don't want that tie to be net required. It might still be that the best architectural design is to do that, but you can separate that. You can say, well, I can still interact with that smart contract even if I'm on another chain.
So you don't want to rebuild the logic assumption.
Yeah, and then, I mean, the other thing is even from a token economy perspective, is can you create, and this is what we're working on in our own supply, is can you create token supplies that are native to multiple blockchains without duplicating that supply? So, very unlike a fork, you get Ethereum Classic, Bitcoin Cash, you essentially duplicate the entire supply at this moment of forking. In this case, can I run two parallel versions of the same application that each rely on the same supply of tokens, where if I move supply from blockchain A to blockchain B, it doesn't duplicate the supply, it just burns and recreates and vice versa. So you can still say, hey, I've got a constant supply of 100 coins, but 50 of those coins are on blockchain A, 50 are on blockchain B, and as I move them over, it goes 25, 75, whatever the case might be. So we're trying to detach this concept of supply from this single network that underpins it. In our model, from like a native coin perspective, the way we do that without impacting the reward mechanism is our inflation model and our monetary policy is a factor of how many coins are on the network that you're validating. So if we end up with a network with multiple Aion main chains, which is kind of the longer term design, is you end up having multiple Aion main chains that act as routers, and you still have the same supply of Aion coins, you might have a third on three, let's say there's 3 Aion main chains. So then the reward is calculated on the basis of your inflation, but multiplied by how much of the total supply exists on that chain versus the total. So, if you have 500 million coins, you've got, 100 million, 200 million, 200 million, then it's a factor of that calculates the reward for the miners. Meaning if the users decide to move their balances, then the reward for the validators goes down. And then the validators are more likely to move over as well. Because then, with the supply goes the reward. And then we put the power back into the hands of the user rather than keeping it in the hands of the validator to say which network should we be supporting. Where right now, a lot of the debate around forking systems is that the miner is kind of the absolute power. If they don't want to upgrade, then they just kind of like get stubborn and stay on the old version of the protocol because it's more profitable for them or whatever. So they just create these stalemates that are very evident in Ethereum and Bitcoin today. So we're trying to move away from that with this concept of like bridging to upgrade rather than forking to upgrade.
Because it also makes it easier, for example, if you start off with a project on one chain.
Yeah.
And potentially it's or we can say it's a crypto keys, right?
Yeah.
There was another chain after the fact that it found out it might help them, either through the one, either the case may be.
Yeah.
You can actually use a bridge.
Yeah, migrate it over. And the other thing is, I don't know if you're familiar with like Ether Delta as a decentralized exchange software. So Ether Delta, very cool design in the context of Ethereum, token for token swapping and exchanging, and not the most sophisticated set of tools and interfaces, but it's functional. So could you build Ether Delta such that tokens on multiple chains could be traded for each other through that same interface? And it's the same thing that Bancors, the reason we're talking to Bancor is that if you look at the Bancor relay system, it's essentially a token exchange system for like single pairs in smart contracts. So you can have like the BNT token to the Aion token or the BNT to Ether or whatever. And they have these smart contracts managing these pairs. And these pairs are essentially liquidity pools of token A and token B. And as you buy or sell one, the pool kind of self-adjusts to reflect BNT or Aion, for example. But they can only do that with tokens on the same system. So what they're trying to do is build the smart contract feature that would allow a bank or relay to exist with token A being on blockchain A and token B being on blockchain B, and you can still have these like self-adjusting smart contracts. And that today would not be possible. Did you have another question? Oh, there's one behind you. Yeah.
So with the variety of blockchains that you're going to have, if we take an imaginary blockchain that, we could take IOTA, it doesn't have transaction fees and things like that. So now if they try to retrieve something from Ethereum, how do you say things like gas price?
So part of this concept is what we can't control in this system of many blockchains is how each blockchain is architected, right? So, you want to go and trigger a transaction on Bitcoin, you're going to be stuck with a Bitcoin transaction fee and a Bitcoin confirmation time. There's nothing that we can do to change that. So depending on the route that your transaction has to go through, then you're going to have to deal with the individual fees that are related to that route, right? So if it's something that goes and triggers, an IOTA transaction that is intended to trigger an Ethereum transaction, then the end of that chain of events is a fee on Ethereum, essentially. At the individual intersections, the bridges themselves can either be anywhere from free to infinite price. The economics of these bridges are dictated by the bridge builder. So the bridge concept is that, hey, there's a registry contract on the Aion network. I instantiate a bridge by staking tokens into that contract, and I design the economic structure of the bridge, meaning what's the fee structure when a transaction passes. I can make that fee structure 0 if I feel like just being charitable and offering a free infrastructure to the market, which we might see. You might see that nonprofit institutions offer bridges between like two nonprofit situations, or governments get involved in offering bridges between critical market infrastructures like stock markets to currency markets, for example. So it can be free, or it can be a fee for service based on what's profitable to the individual validator on the bridge. And the bridge is very lightweight. There's no like compute function associated with it, meaning you don't have to take into consideration the input cost of like energy or compute like you would on Bitcoin mining or Ethereum mining. So it's just a matter of like finding that market equilibrium. If somebody prices a bridge too highly, probably somebody else is going to build an alternative bridge that's cheaper until you get to that point of equilibrium where this is the right fee for the bridge. So we'd expect that price goes down to relatively immaterial as long as it's covering the cost of operating the bridge plus like a small margin to make it worthwhile to do. But the bridges will not be massively expensive because they don't have the same compute requirement as consensus on most networks. So, and they don't have like a huge, you could probably run a bridge node off of a laptop if you like. It's a light client on 2 blockchains and a very, very simple voting mechanism on the bridge. So it's not like a massive hardware requirement. Yeah.
So if there's no computation involved, how does authentication work for bridging?
So in terms of, let's use Aion and Ethereum as an example. Essentially what you would do is you'd run a light client on either of those 2 networks. So you'd have to have the ability to prove state changes on each of those 2 networks. You don't have to do that by running a full node. You can run light clients on those 2 networks, which is relatively lightweight in requirements. And then on the bridge itself, it's a BFT style algorithm, meaning it's a voting mechanism. It's like a single round vote to say, hey, I saw an event with a flag that intended to get picked up. And then you message the rest of the bridge members and say, I just saw this event. Can you all validate that you saw the same event? If we saw the same event, then that consensus allows the bridge message to get passed on. But that messaging protocol is extremely lightweight. There's no compute behind that. It's just it's receiving and sending transmissions essentially. Yeah. Sure.
So I have to admit, I haven't read the token paper yet, so this might have been answered in there. But the one thing I've been wondering about, like some specific blockchains won't have a native Aion token in them. It won't be possible, for example, blockchain. So if I originate the transaction there and I want to send my Bitcoins to the Aion X, how do I do it that without having Aion to pay for transfer fees?
You're talking about if I.
So there isn't a native token for me to fund the bridge transfer with because it can't exist in the native blockchain.
Yeah, I mean, it's a good question. I'm not even sure we specifically addressed that in our paper, other than the fact that I can imagine that at the transaction layer, as the author of the transaction, you may be able to call on like a decentralized swap function, like exchange function, to pay a fee as you go. It's a good question though.
Maybe like an atomic swap.
Yeah.
That's on the bridge.
I mean, the other thing is that what we envision is that over time you could probably end up creating supplies of that token on these blockchains. Bitcoin being a tougher example, unless you end up using something like RSK, where you could have kind of a smart contract layer sitting on top of the Bitcoin protocol, and maybe you then end up kind of instantiating like a proxy token that represents the Aion token as part of that network. So that might be one solution, but we actually don't call that out specifically.
Because I'm just seeing that becoming more and more popular, especially with like medical chains and stuff. I mean, they won't have that token there.
No, and I think what you'll end up finding is that if you're a private chain that doesn't have its own economic currency system associated to it, probably the bridge acts as a service provider to that chain. Meaning the bridge might actually be a commercial service that a group of entities provides to an industry. So you say, hey, I'm now this, and this is actually what we're pitching to a lot of our former enterprise clients, is that this new infrastructure actually might open up new revenue opportunities as they lose their, the relevance of their centralized business model starts to get chipped away at. Then, what they could do is start to see the business models in being validators and nodes on these networks or nodes on these bridges. And what I could imagine is that, hey, I've got this network of hospitals, none of whom touch crypto, but to participate in this network, they're paying some sort of subscription fee in the traditional sense. And that subscription fee is then being paid to whoever's actually managing that bridge that brings them into the public ecosystem. And that bridge is now taking care of all of these like details of like who's putting a token into the system, who's not. Because I think you'll end up finding that most end users are not going to be holding these tokens themselves. They'll probably be relying on services to do that for them. And that's where, you probably pass the buck on to some people.
So when you mentioned earlier, like, you guys would provide 90% on the bridge and then the other 10% is obviously the main data.
Yeah.
So in there, they could say, okay, but we're going to take a 1% Bitcoin fee. And
sure.
We'll have Aion there.
Yeah, totally. Yeah. So the bridge could design itself that way. And probably it's, you'd probably end up in like a semi-layer of like centralization at that point. But again, it comes down to the bridge itself, and it depends. You can use any bridge you want, whether it's centralized or decentralized. It comes down to like market adoption, right? If it works and if the industry that it's intended to serve is comfortable with it, then they'll use it, right? Like if there's like a layer of I'll pay Bitcoin and I'll use my Aion to pay the transaction fee, that's probably a solution that emerges just as a result of like an open marketplace for this. Anything else?
Yeah.
You got one more?
Afterwards, ask him afterwards.
All right. Did everybody end up getting a chance to fill out their little card? All right. We can chat after. If we got all the cards filled out.
Yeah, I figured I would collect them all. We should hang out a little bit more, and then we'll do a draw.
All right. Cool. We'll do a draw in a little bit. We'll do.
Just encourage everybody to try to take part in the public testnet and be involved in our GitHub and our forums. Sign up for our Telegram. And thank you guys all so much for coming. Let's have a round of applause for Matt. For helping us organize this in this great space.
We'll talk to you later.
And that's it.
Yeah, please turn out.
Cheers.